Hi everyone, welcome. In this video, we are diving into Apache Hive, one of the most important tools in big data world. If you're working with Hadoop or aspiring to become a data engineer, Hive is something you must understand. So let's break it down in the simplest way possible. So what is Hive? Hive is an open source data warehousing and SQL like query engine built on top of Hadoop. In simple words, Hive lets you run SQL queries on huge dataset stored in HDFS. You can think of Hive like HDFS is a storage box and Hive is a tool that helps you query what's inside that box using SQL. And honestly, if you know the best part, if you know SQL, you already know about 70% of Hive. Now before we go further, let's see what is difference between traditional database and Hive. In a normal database, data is stored in a local file system. So whenever you want to modify the data, you need to match the schema. That is why it is schema on write, as well as metadata is stored with the data itself. But in Hive, it works differently. Data is stored in HDFS and this data is spread across multiple machines. Schema is applied only when you query the data. That is schema on read. Also, the metadata lives separately inside the Hive metastore. And the key point here is Hive doesn't modify the raw data that is stored in HDFS. It only reads the data when you query it and it applies the schema whenever you are reading the data. See why Hive is useful in big data. So Hive is extremely useful in big data environments, especially at enterprise scale. Here's why. The first point is SQL interface for Hadoop. Before Hive, you had to write long MapReduce programs in Java just to run a simple group by. Hive changed all of that by giving us SQL for Hadoop. Hive can handle huge volumes. It can scale to petabytes of data. It can do schema on read, so you don't need to transform your data before storing it. Just load the raw CSV, JSON or logs into your HDFS and Hive handles the interpretation later. It can support multiple file formats. For example, CSV, JSON, ORC, Parquet, Avro. So it provides a flexibility in data processing. Hive tables can be easily accessed by other big data tools like Spark, Impala, Presto. So why do we even need Hive? So the problem here was initially you had to write the long MapReduce programs in Java and it was not helpful for the people who are not so jargon in their programming language. So they can now just use SQL like Hive language to query their data or to get any if they want to do any calculations or anything, instead of writing more lines of code, they can just write a simple SQL one line query to get the data. So this was the problem, and the solution is also given by the Hive. And Hive actually converts internally into MapReduce stage or Spark job. So now you don't have to write into MapReduce stage or Spark. Hive, you have to just write into SQL and Hive manages is it easily. For example, a company wants daily sales report from logs stored in CSV in HDFS. So without Hive, what he has to do? He has to write a complex MapReduce jobs. Also, Java programming knowledge was needed. Also, time consuming development. Instead of that, just write simple SQL queries, and SQL is familiar for all the data engineers, and it would be a quick development time. If you see the lines of code, it is only a smaller lines of codes. Just write select you can do the sum over here and you can get your data. Hive handles parallel processing across HDFS, and SQL is familiar for data engineers. Alright, now that you have understood what Hive is and why it matters, in the next video we'll get hands-on. We'll create databases, tables, understand managed versus external tables, and explore how data is stored in HDFS. So let's meet in our next video. Thank you.